Hi, everyone. Welcome to our May community call. We're joined today by some people from Serverless as well as Tyler Carter from WAIR. And so we've got a lot of great things to cover today, a couple of product updates, and then a serverless story. And we'll have live Q&A throughout today's presentation. So you might notice that there is a questions tab in this user interface on the bottom right. So if you click on that, you can type in your questions. And then people have the opportunity to upvote those questions. So I encourage you to put those questions there rather than in the chat, just because it's easier just to refer back to those. So we'll be referring back to those questions every once in a while. And while we're going over today's agenda, just it'd be great if you just typed in the chat like your name and where you're from. So I'm Steve, and I am currently in Washington State. And I'd love to see where everyone's from, and we usually have a pretty good global audience. So in today's call, we're going to be kicking it off with an update to the serverless framework with Serverless Compose. So Matthew Napoli, our product manager for Serverless Framework, is going to be demonstrating the power of that, and that got recently released a couple of weeks ago. And then Gareth, our developer advocate, is going to be introducing you and giving you an overview of Serverless Console. So this is our newest product that's currently in early access right now that everyone can try, and we'll give you instructions on how to access it in just a couple of minutes. And then Tyler is going to be sharing his story of how they're using Serverless Framework with this company called WAIR. It's a really interesting story. It's a combination of them using Serverless Framework for machine learning, as well as auto-scaling their architecture for the retail industry, where they've got huge traffic swings, especially around Black Friday and Cyber Monday. So that's a really interesting story about he'll be sharing his experience. And if you have questions for Tyler on how they did certain things, this is a great opportunity to ask him questions too. So why don't I hand this over to Matthew and tell us about Serverless Compose.
Okay, let's get started then. I will do a demo, so hopefully everything goes as expected, which is very rarely the case. I'll share my screen. And let me know if there are questions while I do the demo, because I cannot see any chat right now. So I have my terminal. I have a project to demo Compose, which is a new serverless framework feature that is released in the latest serverless framework version. And Compose is about deploying multiple services. For example, if you are working in a mono repository, if you are working with a team and you have multiple serverless.yaml files, so when I say service, I mean a serverless.yaml file and all the functions you're deploying. If you have multiple of them, you have to deploy them. You have to orchestrate them. And like in our experience and when talking with users, we saw that there was a need for something to help here. That's what Compose is about. So I will show here a very simple project, like let's say an application, an e-commerce application. I have 3 services, something to deal with my products, with my orders, and my billing system. Each one of these is a very simple one, but each one of these is a separate serverless framework service, which means each one has a serverless.yaml file. If I take my products, as you can see, it's like very simple. And without Compose, like I can deploy each one of them with serverless deploy as usual. That works, that's fine. But when you have 3, you have 5, you have 10, or even like 50 services, we've heard about users with 50 services. How can we make that simpler? That's where Compose comes in. So I'll collapse these and look into serverless-compose.yaml file. This is not serverless.yaml. This is a new file with a slightly different syntax. So you can create that file at the root of your project if you have a mono repository. And here I can reference my existing services, right? I have a service key, and in there I have each service with the directory. If you have a different layout, obviously, like you could have the services / whatever, or I mean, it can be any name. with the directory. It doesn't have to match exactly like I did here. Now that's great. I have that. The good thing now with Compose is that I can deploy all of these services with just one command instead of 3. So let me switch back to the terminal. I am at the root of my project. Let me just show you. If I list, I have orders, billing, products, and serverless-compose.yaml. I'll run serverless deploy as usual, but Compose will kick in and deploy my 3 projects in parallel. Now this is very fast, so let me run that again because I have no changes to deploy. This is intentional because CloudFormation is a bit long, so I deployed the project already. But the idea here is that each deployment happens just like as usual. It's like running serverless deploy in each directory. I just have one command to type. Obviously, here this is a simple scenario. Let's dig into the features because Compose deploys by default in parallel. But usually when you have many services, you may have dependencies. You may have to deal with like, oh, I need to deploy products first and then billing maybe. And we can do that with Compose. So let's say I want to deploy billing after products. I can use the depends on feature and say that billing depends on products. I can also add a list of services, so products and orders. Now when I deploy, well, these two will be deployed first. So let me show you. Products and orders are deployed first, and when they're done, billing will kick in. Again, this is very fast here because CloudFormation doesn't have any change to deploy. If I did, it would be a bit longer. I could do as well. Let's have a bit of fun, just nest dependencies. And we've heard that like in some scenarios, you have one that depends on another one, that depends on another one, that depends on another one. That works. You can do that. So here, if I deploy again, it should be product first, then orders, and then billing. You can do any order you want. The one thing you cannot do is circular dependencies, where product depends on orders that depends on products. That doesn't work because we cannot really create an order for safe deployments. So that's the depends on feature that lets you, order deployments. But there is something else that can be useful as well. Let's clean it up. In some cases, we have to pass values between services. So let's say in my billing service, I want to get the latest orders to generate the invoices or to, process them. So billing needs to call orders. And to do that, well, if I go into my billing service, which is again very simple, what I did is I put the order API URL as an environment variable. And here I can hard code the URL, so I can do that manually. And I'm sure you have plenty of scenarios in mind, like I could use .env files or configuration files to store the URLs, maybe deal with different stages. I could use SSM parameters. Some people also use CloudFormation exports and imports. That's a possibility. And it's always, if you've done that, it's always a bit tricky to deal with. With Compose, we've tried to make that simpler. So let's go back in Compose. What we can do is we can use the new Serverless Framework v3 feature, which is parameters, and use them in Compose. So I can pass a parameter to my billing service. I'll call that orders API. And here, this is the beauty of Compose. I can do, orders dot API URL. So what will happen here is that when that service is deployed, Compose will retrieve that output from the orders service, get the value, and inject that into billing. And I will dig into it. What do I mean by output? I mean CloudFormation output. So in orders, what I did is I manually created a CloudFormation output. I could do the same for bucket ARNs, database, table names, queue URLs, or whatever. You create a CloudFormation output. So I'll just go over that part because this is, CloudFormation. It's maybe a bit complex to explain, but I could do anything here and again expose bucket ARNs and whatever. I expose that the CloudFormation output, and Compose will retrieve that value, resolve it, pass it as a param. And then in billing, I can use that parameter. Let's do that. This is the new V3 syntax, orders, API, and that's it. Everything is dynamic. And if I deploy multiple stages, let's say I deploy dev and prod and a new stage for each pull request I have in my project, then the correct value will always be resolved. So let's try and deploy again. This time it will take a bit longer because we are deploying CloudFormation changes, but let's go through it. Oops. Did I miss that? That's what you get from using Serverless Framework every day. Okay, good. So as you can see, we didn't use the depends on feature, but still the deployment was ordered. And Compose will do that automatically for you because billing needs the output of orders. So orders is deployed first. And when orders is deployed, Compose can then fetch the API URL or any output and inject that into billing. And now billing will deploy. I will take the time that this deploys to show you another feature of Compose, which is like a minor feature, but I kind of like it. It's the ability to toggle verbose logs on demand. So I'm here, like the deployment is running here, and it's weird. It's taking a long time. I'm not sure if it's working correctly. So I'll just press the question mark, and then it will switch on verbose logs, and I can go through the verbose logs and see what happens. And this is a good opportunity to show you what happens when Compose deploys. It's actually running the serverless deploy command in each directory. It passes the stage, it passes the parameter that we injected. So this is, if you want to use parameters without Compose, you can. You see, it's just a CLI flag. And the good news about that is that if you have a mono repository, if you have a project in production, you can use Compose and nothing will change on how projects are deployed. We just orchestrate the commands for you. So it's like we made it as simple as possible to use and set up Compose in an existing project. Okay, we have deployed now. Let me show you one final feature. We want to check that everything was deployed correctly. So how are we going to do that? In my billing service, I actually added a log that logs the environment variable. So what we want to do is invoke the function and show the logs. Compose not only deploys, but also lets you run commands across services and even like across all services. Here I'm running the logs command in Compose, so at the root of my project. And this will actually fetch logs from all functions and all functions from all services. What I can do is I can run another command, which is info, which will run info across all services. So I can see info from products, billing, orders. And what I want to do is invoke that function from billing. Let's do that. Serverless billing, which is the name of my service, invoke, which is the name of the command I want to call. And then I see I already typed that. Billing my service, invoke my function, and then parameters. And if I run that, hello world, on the right side, the logs should start to come in. So we probably have to wait a few seconds. There you go. And I apologize because I have some kind of rendering error, but I should fix that soon. We can see the logs. We can see that our environment contains the API URL. Everything works fine. Just for fun, I can show you that I have logs for billing and the function sync invoices, because I can also invoke other, let's invoke the orders API manually. Curl a few times. And the great thing here is that I can see again logs from all functions, orders, API, billing, sync invoices, everything in one place. That's what Compose is about. Obviously, I could also fetch logs just for one service. So I can fetch logs just for billing by prefixing. And I can use any function I want. I can invoke any command from Serverless Framework as well. I'll just stop there. I guess you get the idea. Compose is about orchestrating all of that. And if there are any questions, I will get into that.
Yeah, thanks, Matthew. So I guess one question is, how do people make sure that they can take advantage of the Compose feature? Do they need a specific version of the framework?
Right, yes. You will need to upgrade to the latest Serverless Framework version. I think the exact version might be 3.15 or something, but basically upgrade to the latest version and it should work.
Okay. Great. And then I think we also have some links here for the blog post announcement as well as a link to the docs. You should be seeing like a call to action link showing up in Livestorm that'll take you directly there if you're interested. We do have one question here from Ryan, and this question is, when you're using Compose, is there still a way to deploy an individual service that uses params set in the Compose file by seeding into that service? Or should I just handle all individual service deployments from root with Compose via the serverless service deploy syntax?
Right, so let me share again very quickly my screen. That's a good question, Ryan. And yes, in that case, the idea with Compose is that as soon as you start orchestrating all your services, if you want to deploy a single service, you have to do it from the root. So here, if I want to deploy only billing, I would do billing column deploy. And if I change directory and go into the billing directory, then things will not really work because I'm depending on the parameter from to be injected from Compose. So when you use Compose, you run commands at the root. You can still run any command like offline if you want to, or any custom command you may have with plugins, that works, but you have to do them with Compose.
Okay, great question. Any other questions about Compose? Oh, looks like Ryan asked a follow-up question.
Just a function from a specific service. Yes, exactly, you can. And this is exactly the syntax that you put in the question, Ryan. So, yep, that sounds exactly what you need.
Great. Okay, great questions, Ryan. And looks like Jose posted a question in the chat. Does serverless realize which service has changed and deploy only those with changes?
Yeah, that's a good question. So basically, Compose runs serverless deploy commands. So if I haven't changed the service, which was the case here, the deployment will run, but like it takes 5 seconds. CloudFormation realizes that there are no changes and it will not deploy. So it takes a few seconds. In some scenarios, if you have like a long packaging or compilation process, it may take a bit longer. So Serverless Compose doesn't do anything, but Serverless realizes that there are no changes in a specific directory. What we want to do is we are looking into improving that even further and even skipping the compilation, like packaging. If you use TypeScript, if you use, I don't know, other languages that compile, we want to increase that even further. But long story short, Compose will behave just like Serverless deploy behaves today.
Okay. Thanks, Matthew. So that's a great overview of Serverless Compose. I posted the links to more resources in the chat, and we will also email these links to you at the end of the webinar. So we'll take one more question about Compose before moving on to Console. And so we've got a question from Wes. So he says, I have multiple asynchronous microservices utilizing tooling like EventBridge, SQS, Kinesis, for local development of synchronous microservices. I see where Compose might be super powerful. Is there any guidance for those of us heavily leveraging async for local development?
That's a good question. And I think that depends on how you run local development today. Maybe, so I would be interested actually to discuss that with you, Wes. And I'll get maybe into the chat so that we can see how you run deployment, local development today, and see if Compose can help. Because I don't have the answer right now without more details, I guess. And I'll answer
Right,
future
so
questions like in written form.
great. Okay, so in the interest of time, why don't we move on to Serverless Console? I also just posted in the chat that if you're not a member of our community Slack, that's a great resource, and members of the product team and folks like Matthew are on that as well. So encourage you to join our community Slack if you aren't there already. So why don't we move on to Serverless Console? And Gareth's going to give us an intro. If you haven't started using Console, which is in early access right now, this is a great time to start. So Gareth, let me hand it over to you.
Thanks, Stephen. And I need to follow Compose, so that's going to be fun, but I will do my best. Let's see. I'm going to grab a screen here for everyone to take a look at. Alrighty. Yes, that is the right one. All right. So Serverless Console is one of those, a new product from Serverless, as Stephen has mentioned. And this is something we've developed because it solves sort of a long-standing problem in the serverless world with serverless applications in general, where it's kind of difficult at times for us to work out exactly what's going on sometimes with our serverless applications. I mean, in the traditional server-based world, you had a machine sitting there with a CPU and RAM and stuff you could take a look at and kind of gauge what the health is of everything. And there were a lot of tooling around for that as well, that as you see the health of your server-based architectures. And serverless sometimes looks like a bit of a black hole. It gets a little difficult to look at. And a lot of the other tools out there that are sometimes designed to try and help you give you this observability can be a little difficult or confusing to use. A lot of them need a lot of configuration for you to get things sort of set up the way you need it to give you the information you need to help keep eyes on your serverless applications that you're busy building. And Serverless Console is our answer at Serverless to this potential problem. And what you can see on the screen is ultimately one of these sort of panes of glass, a single view on an entire organization's functions. And the idea here is that we want to provide tooling for folks building serverless applications based on what kind of use case they want to view at the time. So while we may be looking at the functions in the organization over the last 24 hours right now, I can switch my view to look at the APIs instead. And a lot of organizations will have functions that will operate using events that trigger them, like SNS, SQS, S3, Event Bridge, DynamoDB, and so on. But sometimes you need to see just what your API is looking like. And instead of looking at functions, you're looking at API endpoints instead. And here, this is all focused around what your HTTP requests look like, which of those returned errors, and so on. I'm going to just switch back to the function view because that's what we'll be looking at through this demo. But the idea here is to provide you with more and more of these views that get you right into that specific sort of use case or view that really gives you the data you need to keep your applications maintained and running. And immediately here, looking at the functions view, I can see there's some very important information that we've made bold and clear, is that errors. Errors is often the first thing you want to make sure to look at and target. And like I said, this is organization-wide. And I can just click on my errors here, and immediately this entire page is going to filter based on the errors my organization is experiencing. And I can immediately see there's just one Lambda function here affected by all these errors. And now let me get into debugging them. I need to fix these problems. So there's a few ways to do this, but the easiest way is just to find a particular timeline that looks appropriate. This one has got the most errors in, and click through. By clicking through to that, I can now get a list of the specific invocations that errored out during that time frame I clicked on. And once again, I want to get more in-depth information about the specific errors. So let's go through and click through to one of those and look at this in a lot more detail. And right here, I start getting a lot more information to help me out. First of all, I might want to go to my logs, because obviously if there's an error, there's probably going to be a log with an error message somewhere. And what happens here is that we have logs that are pulled straight out of our Lambda function. And in this case as well, CloudWatch isn't necessary for these logs to function. There is no need for CloudWatch to maintain these logs or retrieve these logs. We are able to integrate into the Lambda function in a way that helps us retrieve these logs direct as the error is happening, which is a really big advantage. The other side of this is that I now have instant access to the error message, so I can immediately see the error message that happened, as well as a stack trace, which gets me to the exact line in my file to go look at and debug. So just taking a look, I can see this user has non-admin and needs admin instead. So instead, let me go take a look at something else that we briefly saw. And here, I want to take a look at my event object. So what we've done is we've provided you the data that was sent to the Lambda function directly, the event object that is passed from API gateway in this case. And I can look through this and immediately go through to my authorizer and see that the role that was passed for this specific invocation was non-admin. And that makes sense because that's what my log said. My log told me that the user has non-admin and needs admin. Great. I've figured out what the problem is here. But maybe, for example, this error isn't quite as simple as this one is. And maybe I need to get more members of my team involved to take a look at this. It's more in-depth. We all need to take a look. I know who's responsible for this. I can click on the specific log line with the stack trace. And what we've done is we've now altered the URL in a way that if I copy and paste this URL to my teammate, he's going to be directed directly to this page, but also directly to this specific log line. So that I can pinpoint exactly to him what the problem is. And any other of my teammates, however many that may be, can all be on the same page looking at the same error and getting this fixed nice and quickly. Really useful in that way. So you also may have noticed while we've been looking at this page is this timeline section here. And what I'm going to do is I want to look at something with a bit more interesting data in the timeline. And one way to do that is I'm going to use a feature called the Explorer here. And the Explorer is a great way for me to go ahead and filter through, whether it's the API endpoints or the Lambda functions, filter through the different metrics that is available to find the exact items I'm looking for to edit. And hypothetically, I've received reports of a Lambda function that seems a little slow. It's creating latency. So let me go look at the function names, and I could filter by service names, environments, whether that's in prod or dev, the regions they're deployed to. But I'm going to pick function names here, and I'm going to look for the specific function name. Here it's thread details. Let me just filter by that. So over the last 24 hours, let's just change this. I'm going to make this 7 days. Why not? Let's filter by this function over the last 7 days. And let's find this one. It seems like it's taken a bit long. So let's go take a look at this one as an example. Wouldn't you know that happens to not be as nice a one as it could be? Let's just find this one here. There we go. It's another one. It's good enough. What the timeline here gives me, though, is a feature that's automatically embedded within the use of console. When you use the console with your serverless framework services, you automatically get these features like the timeline trace here. And what this does, for example, is it'll show me interactions with the AWS SDK and a number of other things, which I'll get to in a second. But in this case, for example, I can see that I have a get item request to DynamoDB here taking 178 milliseconds. That seems a little long. Maybe I can do something about that. But I've got this information to hand. I can even immediately get to the actual object that was sent to DynamoDB for the item that I'm looking to retrieve in my code. So I've got information here. I can immediately go and see about optimizing this. But the timeline's useful. The timeline trace is useful in many other ways because the Serverless Framework Console also makes use of the OpenTelemetry standard and OpenTelemetry libraries. So what this means is that if you happen to use a framework like Express or others that support OpenTelemetry, then you will have features such as this in the timeline available to you. And because of Express's support for OpenTelemetry, if I use middleware in my Express, or if I happen to make HTTP requests, these automatically get instrumented for me with no additional work by me as a developer on the team. So what I can do here is I can immediately see my middlewares are probably not the cause of the latency in this application. We can immediately see all of these are pretty quick. I do have an HTTPS post here running at 111 milliseconds. So just clicking on that gives me a lot more information to work with. And I can immediately start seeing what the problems might be happening based on that timeline trace. So that is the very quick rundown of Serverless Framework Console. As Stephen mentioned, this is in preview at the moment, and we really do want folks to try console, sign up, and give us feedback. This is being built alongside feedback of customers that are using it right now. So yeah, it's freely available to try out and use. And if anybody has any questions, please feel free.
All right, thanks, Gareth. Appreciate that. So as you mentioned, this is available for early access to anyone right now. So you can visit the docs to learn more, or you can get started immediately just within the CLI by typing in serverless -- console. So it looks like we've got a couple of questions. And let's see here. I'm not sure that these are related to console necessarily.
I
Gareth, do you
see.
want to take a look at those and
Sure. I
adjust?
see. I see Ryan has a question that says we use serverless plugin warmup for a bunch of our API endpoints. The warmup invocations fill the dashboard with noise we don't care much about. Any chance there's a feature in the works to filter out events if they're triggered by the warmup invocation? That is an interesting question. That is, we are focused on building filters that meet your needs. I don't think we have one specifically targeted towards plugin warmup, but that is one of the reasons why we have an open preview on console right now, so that folks can get in, start using it, and provide us feedback on stuff they would like to see. So something like that is some pretty useful feedback that might lead us to finding a way to build a general sort of filter feature into console to help with use cases of that type. So I would recommend potentially dropping into console and taking a look, Ryan, and just giving us that feedback, speaking back to us about the type of stuff you'd like to see as well, so we can get that back to the team.
And I should add that this is still, as I mentioned, early access, but we're rapidly adding new features to it. So I think some things that are on the near horizon include like live dev mode for streaming logs and things like that. Are there any other things that you can share that's coming up, Gareth?
Yeah, Devmod is one of those I'm very, very excited about, because it's taking the idea of developing in the cloud one step further, and actually will work quite nicely with Compose as well, because that it kind of ties in together quite nicely there. Because the idea is that we want to get logs out to users really, really quickly when you're busy, developing in the terminal. And as you saw in Matthew's demo, when you're tailing logs from CloudWatch, it's not super slow, but it's not super snappy either. And
Yeah,
our
it's
idea with
frustrating.
it can be. It's not terrible, but it's not great either. So dev mode is really awesome, because you can essentially tag dev mode onto a function, invoke it, and have instant logs coming back to you. And it's pretty killer for that. It's still a feature that's being worked on by the team. And there's a lot more. I mean, there's the one downside of sometimes being in the discussions is that there's so much talk about what's going on that it's sometimes hard to keep track. But yeah, dev mode is definitely the big feature that I'm really excited about myself.
Great. Thanks, Gareth. And let's move on and bring Tyler Carter to the stage, and where he can share their experiences using serverless framework for their company WAIR. So Tyler, let me hand it off to you.
Great. I'm Tyler, and happy to be here, chat about serverless. We're obviously big serverless fans overall. And with WAIR, just to set some context, so we help e-commerce shoppers find the best fitting size. And the best way to kind of think about it is, how you go to buy a shirt, for example, and maybe it's a new D2C brand you haven't purchased from. I'm kind of between a medium and a large, and I don't really know what to do at that point. It's just frustrating. And so the solution we've created is, when you're on that shirt screen and you see medium, large, you don't know what to do, that you can pop up a widget, ask you a couple questions like height, weight, age, and then gives you a recommendation based on that data for what size to choose. So in terms of the problems it solves, we're a B2B2C brand. So for the shoppers, we help them have confidence buying the best fitting size, especially if you're new to a brand and haven't already kind of purchased a couple sets of sizes, or there's not good size alignment across the catalog. And then for our customers, which are the merchants, that we help improve margins. So growth at all costs is no longer really the case in ecom, and so helping increase conversions, lower returns, and the other piece that, as people use our service, they've really found value in is more information about the customer, and not just technographics that you usually get, but also body dimension data. So it contextualizes a lot of the other data they already have. If I'm X brand and I have a bunch of review data from Yapo, and it's 30% of people said a large fits too big and 30% of people said a large fits too small. but without knowing who is saying what from a body perspective, it doesn't really mean a whole lot. And so we, are helping those brands understand, all right, it's the 6'3", 170 person like myself is saying the large is too small or too large, too big, and it's the I don't know, 180, 5'5" person that's saying the large is too small, and that adds really important context to reviews or returns or other data that these brands are collecting. We work with customers like Fresh Clean Teas, SheFit, Vineyard Vines, Cuts, Roan. A lot of basically any apparel brand that's focused on e-com, they have the problem we're solving. So we've continued to grow over the last couple of years, and working with bigger brands as well. And then the other part of our team that's obviously related to using serverless is we're the company is 20 people, but the dev team is effectively 5 people. So we have myself and another backend developer who we've really built the whole backend and architected the system together. We have 2 front end developers and a data scientist. It's we definitely prioritize having a senior team, but 4 engineers and a data scientist, I think, is pretty common, in terms of a size, and just to kind of set the stage on where we've been excited about, the serverless recently is how to fill that gap between the data scientists and the engineering team. And the data scientist is building models, and they have to get into production, and there's just the 5 of us. So finding a way to really make that an easy process is a huge challenge that serverless has helped us solve, along with a myriad of other things. So a little bit more about our products, just so you get a look. We're coming out with a new look to our sizing plugin. So just throw it up here. You guys can see it. It'll be out in about a month or so. And so this is our WAIR sizing plugin. This is what you'll see on the site. And then I'll share a quick demo. Just get it pulled up. So this is a little green to begin with, but it'll pop into focus and I can replay it. So you can, let me just pause here. So this is it's still apples and handling, but you enter in height, weight, age, and then as you're going through this, it will ask you a couple questions about your body. So you can go through quickly, but different segments of your body, and you get to the end, it makes a recommendation. And then once you have gotten your recommendation, then wherever you go on the site, and I'll just go back to wherever you go on the site, then it will just follow you around. So just because I got my recommendation on this shirt, then when I go look at a pair of pants, we've done a prediction on your body behind the scenes. And so now when I go to a pair of pants and I don't know whether I'm a 33 or 34, then it will use your same body prediction and compare that to the actual garment and say, well, based on your body dimensions, you should wear a size 34 pant and it will fit you slightly loose. And so as people go around the site, our kind of end goal is really to give this, we call it sizeless commerce. So you're not thinking about sizing as you're going around and purchasing products, and really just focus on what your preferences and have more of a personalized experience. So flipping back to the deck, there we go. Oh, let me share one more time. So this is, and then on the other side, this is what our customers see. So kind of the performance metrics you'd expect around just tracking what impact the WAIR sizing plugins having on their site. But then also we help them understand. So this page is our product insights page, and it's showing what's happening at a product level. So who's buying my, maybe my shirt that sells is the most popular. Who's buying it? Who's not buying it? Who's returning it? And looking at body dimensions and distribution. So it looks like all the tall people are returning a medium of this shirt, and really giving actionable context so they can decide, all right, well, maybe I need a medium tall in this product because anyone who's tall is returning the medium. And then going a step further, getting into serverless. So that's where and what we're doing in the use case. But for serverless, breaking out kind of our different technical use cases, we have APIs, JavaScript REST APIs backed by Dynamo. And these are high volume requests, there's binary requests, analytics reports that are a little bit longer run into Athena, data model hosting, so allowing prediction inference to happen in real time, and then also ETL. So we collect a lot of data. We need to move it from Dynamo or S3 and put it in a place that we can run Athena on top of it. And as called out, just you need to do a little bit of aggregation just to make sure that things are reasonable. If anyone's used Athena, the scanning costs are no joke. So you got to make sure that things are in a place where you can run your reports without spending a fortune. And then the last piece in ETL is we're collecting a lot of data from the e-com brands themselves. We need all their products and order information. So especially, there's a lot of high volume e-com brands that we need to take in a lot of data. So we're running that all through Serverless as well. And this is a look at the architecture. So over here on the external side, we have the shopper who's on an e-com site. We have our customer dashboard. And then I just throw on admin consoles here, our internal team who manages, what happens for certain brands and ensures that all the things behind the scenes are running successfully. And then down here at the bottom, there is the e-commerce platform. So integrating with Shopify, BigCommerce, custom platforms, if you're on Salesforce, for example, or others that are kind of in the larger scale brands. And so we have a couple different routes. Where I'm going to focus most on is just from this traffic from the shopper. So we are on brand sites. Every time a shopper goes on a brand site, there's traffic to our endpoint, and even just to show our widget. And we initially did everything just writing to Dynamo. Eventually, the event traffic is high enough that we needed to route some of it through Kinesis. And when someone goes through the process, they are doing kind of the REST interactions. But then there is a prediction done that's needing to make a prediction of real time using data models like scikit-learn, for example. And so I added this Lambda here. I guess I'm not sure if you can see my cursor, but kind of in the center of the screen, there's a real-time inference model. And here we, when it's hit by the widget API Lambda, it is first downloading the model from S3. So we put it in temp storage, which then is basically effectively does caching when you're running a number of inferences within a 10-minute period. And so the models get downloaded to the temp storage, and then we can run our Python code against that to run the inference. And originally, we're using serverless to do this in the kind of before the previous limitations of Lambda, which was you sort of like zipped up a bundle of Python code and libraries, then downloaded it. You're always about to hit like the unzip limit, and it was pretty challenging. We were always like limiting what our data scientists could do based on our space on Lambda. And then with the new Lambda limits of allowing more storage and more resources, we've started to leverage the image support for for Lambda and through serverless. So this is just to dive a bit deeper. And if there are any questions afterwards about the rest of the architecture, happy to go into that. But just want to stay a bit focused on this piece. And if you are trying to if your goal is my data scientist has built a model and I need to host it and hit it to get an inference done, then this was definitely an unlock for us. Serverless or SageMaker is an option in AWS, but it's definitely a lift as a non-data scientist to go in, set up SageMaker, make sure it works. At the same time, if you're a data scientist, that's not a trivial task either. And so this was our solution to, holding out on using SageMaker until it was absolutely necessary. You can train a lot of great machine learning models locally and host them in the cloud without having to do everything in SageMaker. And so this is the code we use. There's, I think, one example out there that I found that was pretty good. But it feels like there, should be a lot of articles that just describe this so people can leverage it. And effectively, we have our serverless YAML file. It should look pretty familiar, but it pulls a container image from ECR that you can see over on the left side. And then we just have this one function. So when you hit the serverless function, you're just hitting exec, and it has an entry point into the container. So then if you look at the Docker file, and small call out that got me, if you have an M1 Mac, you try to deploy this, it will fail unless you add the platform specification. So, save people a few hours of sleuthing. But then your Docker file is, pretty basic, 4 or 5 lines. You can just put whatever libraries you need in your requirements text file. They get installed and wrapped up in this publicly available Python 3.9 image. And then you hit your handler function. And you don't really have to know a whole lot about Python to just put this in place and then hand it to your data scientist to fill in what they need to do on the handler side. And so at that point, we run some data science logic inside the handler, do the inference, and then pass back some JSON. And it works really well. The cold start is slightly longer, but you can easy ways to just keep it warm. And once it's warmed up, then we saw really little performance drop off from running just the standard kind of Lambda runtime. So for us, that was a big win. We've used serverless across a lot of other services that are more the typical use cases, but just wanted to call this out as it was a big help to us, and I think fills a gap of this data DevOps person who is just not present on a 5-person team. And getting through the last couple of pieces. So why serverless? DevOps can be expensive. It's really me and another person who have built and managed all the serverless infrastructure. We also have a capture side of our business, the 3D body scanning, so all that as well. And you can hire a DevOps engineer, which is expensive. You can use a hosted service, but what we found is a fully hosted service. If we moved our Lambdas onto Vercel, for example, using their, it's not Lambda there, but the same thing is 7 to 10x the cost of AWS. And then we started on serverless maybe 4 years ago, and it's evolved a lot. It was good then, it's still good now, and handle a lot of our use cases. And we're have to be pragmatic as a small team. So we're not going to take on a lot of other frameworks, other things. And so it's been a big win for us to just keep in the same place. So you can only learn so many things while kind of scaling the product, and then built-in scale. So I just called out this piece. This was last year over Black Friday, and this is hourly. So basically between this is over the course of a few hours, we're seeing 7x the traffic and then drop back down. And the first year we did it, we just set it up. So this was 2 years ago, and everything worked flawlessly for the end user. They didn't, they could always like get their predictions and everything worked fine. We had a couple of issues with ETL because we were trying to like process too much data, but we tweaked that. And so last year, I went to Thanksgiving and went through the weekend, and there was no issues. So that was a big win for us, kind of, in multiple levels. Customers were satisfied. We're a usage-based revenue business, so capture all the revenue we can during that peak season or that peak time, and also just less stress during the holiday, which is great, and not the case for most people during Black Friday in e-com. I know we're close on time, so alternatives. We were on AWS. We wanted something that was easier than just using only AWS, and serverless was really that fix for us. The other person who's the other technical lead, he had used it in another project and loved it. So we had a couple kind of initial projects as we kicked off this ecom product, and it was a processing pipeline for validating body scans. It's kind of our base data, and then the API that we've talked about for the sizing plugin, which is a series of different ways, different architecture, and it fit all those use cases. So we were in at that point, and we always look around, but we've never found anything that's fit our needs better. And we use it basically every project. We just think, like, can we use it, and how do we do this in serverless? If we can't do it, we have to go somewhere else. Like, we know that's a big cost to take on something additional. And the one exception I added here just is on front-end hosting. So we use Vercel. It's great. We just use it for hosting our JavaScript bundle that gets downloaded for our front ends. But there's, if you hit a certain bandwidth, like, you start getting charged effectively 7 to 10x what AWS would charge you for downloading the same data. And so we're always excited to keep an eye on serverless and their front end work for React and see where that goes. But overall, we've just been happy to have a little bit easier time building on top of AWS. That's it for me. I'm happy to answer some questions, and it's a bit quick through the process, but we've just want to say thanks again for being here, and we've really gotten a lot of value out of the serverless platform.
Great, thanks, Tyler. And we can certainly go over by a couple of minutes. We've got one question here from Enrique in the questions tab. So his question is, how are your DynamoDB tables structured to handle all this traffic? Are there any specific patterns like a monotable design or something else to tune the performance?
Yeah, so we'd come up from a relational database standpoint where you just put stuff in and then you query it however you want. And I think the most important thing is just thinking about how you need to access the data once it's in there. So if you need to kind of query in certain ways, then the data just needs to be stored to set up, make sure that you can query it, maybe with some indexes to get it back out to the application. So that's really the rule of thumb we've used. We try to, for example, all of our events are just in an events table, and there's different types of events. And then any reporting that's being done, it gets pushed out through ETL, and then it's run against Athena. So think about, from your application where you need data access quickly in Dynamo, Athena, there is some time lag. Think about it from the query standpoint, and then really, building your data models around that perspective.
Got it. And so, again, if there's any other questions, please post them in the questions. But I think what would be interesting, if you don't mind spending another moment talking about how you're using like the Python and like the machine learning stuff to apply the sizing, because I think when we talked in preparing for this webinar, you have your sister company around like the Fit3D and how you're using that body scanning imaging to actually inform the sizing. So can you talk a little bit about that?
Yeah. So the summary of the other side of our company, Fit3D, is we sell 3D body scanners into health and wellness. We've collected about 2.5 million, close to 3 million body scans. And then we basically anonymized all that data and built body prediction models on top of it, so that when someone comes to a website and they fill in height, weight, age, and a couple selections about their body, that we have a model that runs that correlates that to the output measurements. And so for that was really a focus for us, that we weren't relating just because you bought a medium in Nike, that means you're large in Adidas, that we were predicting bodies of every shopper that came to e-com site, and then really comparing that to the actual apparel. And so it's a two-step process for us. So that's the prediction. The other place that we use machine learning for our is the recommendation. So we've predicted a body that has these measurements. We know some dimensions about the garment, and then we need to fill that gap with a model. It's our recommendation model. And so in this screen at the bottom, we have another kind of Python Lambda that's a bit longer running, that does some analysis of these two data sets. So the prediction data and the dimensions of the garment, and then builds a link between those. And that's how we know, not you guys have all bought clothing. Just because you bought a medium that fits one time doesn't mean medium is going to fit in every product for that brand. And so since we know, so then we can make this link between individual products, so that, I bought the shirt, like the 1.0 version of the shirt, and I was a medium, and then I go back to buy the 2.0 version of the shirt, and I may end up being a large now, or maybe I'm in a different region and I'm in Japan, for example, and the large is not going to fit the same way as it does in the US. For a global brand. And so then, we're really just comparing body prediction to the specific garment, not trying to do a kind of garment to garment comparison.
Got it. Thank you. Yeah, I noticed that, like, when I've sometimes bought clothing directly from with the sizing in Asian sizes, I end up being like the Incredible Hulk with like split pants and split shirts. So definitely an interesting experience. All right, so that's awesome. Thank you so much, Tyler. If there's any other questions, please post them in the questions. Otherwise, we can kind of wrap things up and take it away. I'm not sure why the conclusion slide is not here. But Richard, do you want to wrap up today's call?
Yeah, it's no worries. I'm going to actually post the links here in the chat for everybody. And if you just so happen to be watching this video later on YouTube or in the on-demand, just look in the description. We'll include all of the links for today's call as well. Overall, I just want to really thank everybody for all of the time for being here today, and also thank Matthew for covering Serverless Compose, Gareth for covering Serverless Console, and thank you, Tyler, again for covering WAIR and everything you've done with Serverless. And again, if you are looking to share your Serverless story with us, we are looking for more submissions there. I've included that link at the bottom there. And yeah, unless you have any more questions, I'm going to take one more look here at the questions tab to see if any are coming in.
Nope. Yeah, I think, yeah. And then one other note, if you share your serverless story, you'll get an awesome serverless t-shirt, which we just recently started producing. And I've heard that they're a perfect fit. We didn't use the WAIR plugin, but we will if we need to. All right. So as you mentioned, we'll send a follow-up email to everyone who was on who joined and with a recording to the today's call, as well as links to everything that we included here around Serverless Compose, Serverless Console, and also WAIR. So thanks everyone for joining, and we'll do it again soon. Thank you.